Tēnā koutou katoa. Hi to fellow ocean acidification colleagues all around the world. It's great to be able to connect with you via this OA week, to hear about the work that's being done by many people in many countries and to discuss issues that are important and relevant to us. Thanks to everyone involved in organising and contributing to this OA week, and particularly to the team who have pulled the logistics together, allowing us to meet virtually. The IPCC Working Group 1 contribution to the 6th Assessment Report was released last month. Working Group 1 addresses the most up-to-date physical understanding of the climate system and climate change. The report states that changes to the ocean, including warming, more frequent marine heat waves, ocean acidification, and reduced oxygen levels, have been clearly linked to human influence. These changes affect both ocean ecosystems and the people that rely on them, and they will continue throughout at least the rest of this century. They also state that it's virtually certain that seawater pH has declined globally in all ocean basins over the last 40 years, with human influence the main driver of the observed ocean acidification. pH decline having been observed in all ocean basins. Of course, this is not news to us, but the importance and relevance of these statements lies in the specific language that is used. Clearly linked, will continue, has been observed, virtually certain. The observations that are encapsulated in these statements have resulted from decades of meticulous measurements of the marine carbon system by scientists from many countries. The 6th Assessment Report includes this figure, which brings together surface pH observational data from 11 open ocean time series, covering all ocean basins and including the northern and southern hemispheres. The central image shows surface pH, and the blue dots in the time series plots from each site indicate the observed data, covering the 40 years from 1980 to 2020. The blue and purple lines show the annual or winter mean at each site, all showing a decrease in pH. So, observations are vital in documenting the changes that are taking place in the ocean and give policymakers and other stakeholders the information needed to manage and respond to these changes, including ocean acidification. This is what GOA-ON is all about. It's why we're doing the work that we're doing, and it's summarised in the GOA-ON Goal 1 shown here. However, the long-term trends referred to in the AR6 report are from open ocean sites, and we know that many of the impacts will be most heavily felt in coastal areas, with many species, ecosystems, and socioeconomic services occurring there. We also know that coastal carbon dynamics are impacted by a number of other drivers, both natural and anthropogenic, which increase the variability in those nearshore environments. This figure shows how the variability increases significantly from the open ocean to coastal gradient. This increase in variability occurs on many timescales: diurnal, tidal, seasonal, event-driven, and interannual. Bates and al. showed the consistency of open ocean time series trend, ranging from negative 0.0013 to negative 0.0026 pH units per year. Carstensen and al. compiled pH data from coastal sites and showed that there was not only greater variability, but both positive and negative trends. The time for any long-term change due to anthropogenic causes to emerge from the variability is much longer for coastal environments than it is for open ocean sites. This plot from Sutton and al. shows the time of emergence for surface water PCO2, with the scale, the colour of the dots, ranging from 10 years to 40 years at these North Pacific sites. This underscores the importance of long-term monitoring programs. And in the case of most coastal locations, long-term monitoring really does mean long-term, with times of emergence being in the multiple decades. Though of course the value of starting such a monitoring program starts immediately with the very first measurement. So those initiating, supporting and funding such time series who want to eventually know what long-term impacts are occurring in their area should be aware that they are committing for a long haul. I'd now like to talk about what we're doing in New Zealand as an example of what a small country can achieve with relatively limited resources. New Zealand is a small country here in the southwest Pacific Ocean with a large EEZ shown in green and a large coastline including a diverse range of ecosystem types. Like many countries, the ocean is important to us both economically and culturally. The IPCC regional fact sheet for Australasia, which includes New Zealand, stated with high confidence that ocean acidity is observed and is projected to continue in our region. The statement that ocean acidity has been observed in the Southwest Pacific is due to the data collected on the Munida time series, one of the data sets that was included in the diagram that I showed earlier. I'm now going to take a few minutes to describe how the New Zealand ocean acidification community has come together to support an observing network, the New Zealand Ocean Acidification Observing Network, the local GOA-ON. We hope that the work of the NZOA-ON will allow future IPCC reports to assess the impact that OA is having in the New Zealand coastal region based on direct observations. And hopefully this will include the measurable impact of mitigation and management strategies that have been put in place globally as well as nationally and locally. The vision for the New Zealand OA monitoring network was to measure present-day carbonate chemistry at a variety of New Zealand locations and ecosystems. When we started, we had very little information, with sporadic data having been collected using a variety of methods and protocols. So we wanted to gain an understanding of the variability and to identify drivers where possible. Secondly, we wanted to provide baseline conditions against which to measure future change. Our vision was to make a start on what we hoped would become a long-term monitoring program. Of course, at the beginning, we didn't have the resources to commit for more than a year or two, but we realised we had to start somewhere and that any data we could get would be better than nothing. These data could help us to identify areas of vulnerability and potential resilience for local species. The data would be useful to those doing OA experiments and manipulations, providing realistic values and variability to set experimental levels. Scientists weren't the only ones interested, so we wanted to be able to inform stakeholders, including aquaculture, government, the general public, and including Māori communities. We were getting started at the same time as a lot of other work was going on internationally, and we wanted to contribute to and learn from national and international programs, and in particular GOA-ON. Things really took off for us in 2013 when a stakeholder workshop was held with national and international participants. Importantly, shellfish growers, policymakers and scientists from the US came to New Zealand to share their experiences and to talk directly with us. The US shellfish growers talked directly with our aquaculture industry, the US policymakers talked to the New Zealand policymakers, and the US scientists talked to the New Zealand scientists, including me. The monitoring network vision was starting to look doable, with support and interest from a strong and informed community. We started off with 10 sites distributed throughout the country, trying to cover as many different types of ecosystem and stakeholder interests as we could with just those 10 locations. We began with bottle sampling, but with the hope of adding sensors as we could afford them. We then started to form collaborations with those who would take the water samples for us. We used our existing contacts and approached others who could fill the gaps. We explained the issue, the vision, and asked them about their needs and interests. We talked about what we could offer and what we would like our sampling partners to do. We got strong buy-in, so it was all becoming a reality. The alkalinity and DIC analyses are done at a central facility, and we also manage there the logistics and the data. The lab also provides buffer and dye for other institutes and analyses samples from experiments and other OA work. This means we can maximise the use of the equipment and expertise and can leverage the value of the CRMs, maintaining the quality of the data. We got underway in 2015, so we're now 6 years old. Other OA programs were getting up and running at around the same time, so we maintained compatibility with those. Sample partners are provided with self-contained sample crates. And we made a video describing the program and showing how we wanted the samples to be collected. The sample partners are key to the success of the network, and working with them is an important component of the job. We ask them to collect samples using the equipment provided in the sampling crates and adhering to the sampling protocols, to fill in the sample sheets and to keep in touch with us if there are any problems or issues. We also ask them to agree that the data from their site be able to be shared and to contribute to the wider network goals. In return, they have access to the data from the entire network, but I think more importantly, they gain a link to the wider OA community, both nationally and internationally. They are directly contributing to knowledge of the global ocean acidification situation. Most of our original sites are still going, and many of our sampling partners have been with us from the start. I'd like to mention 3 in particular. Barry, a fisherman who takes ocean acidification samples for us from a remote part of the west coast of the South Island. And Cess, who works for the Crayfish Collective on the Chatham Islands, another very remote part of New Zealand. Kevin works for the Shellfish Monitoring Program and takes OA samples along with other samples measuring the health of the water where our important aquaculture industry is located. New Zealand has a long coastline and the ecosystems and environments are diverse, so we are welcoming additional sites to join the network, but we need the resources to do this. Collaboration with other organisations has allowed us to expand. In particular, we are working with Te Papa Atifai, the Department of Conservation, to monitor ocean acidification in 10 marine reserves, and with regional councils who have added ocean acidification sampling to their environmental programs. When working with these partners who pay for the service, we ask that they join the network as a whole, with their data being publicly available and contributing to all of the stakeholders who have an interest. We also emphasise to them that it will be many years before they see any long-term trends. So here are our current sites with the type of sampling partner given by the different colours. Regional councils are shown in yellow. Purple indicates sites that are managed by universities and research institutes. The aquaculture sites are shown in light green and include the ones sampled by Kevin, who I mentioned earlier. Orange shows our collaborators from the fishing industry, with this site being sampled by Barry and this one here by Cess. The Port Authority is in blue, and the 10 marine reserve sites, collaboration with the Department of Conservation, are in dark green. The red sites indicate locations where we work with local Māori communities. So you can see we have a good spread of sites and a lot of people who help us. The data and other information are publicly available via the data portal and also via the GOA-ON data portal. These data form the basis of New Zealand's country reporting towards the UN SDG number 14.3 and are also used by the Ministry of the Environment and Statistics New Zealand for national assessments. Working with local people to help them to understand and to manage their local environments in the changing world is the focus of a new program in New Zealand called Coastal People Southern Skies. This program recognises that people, their physical, emotional and economic well-being is integrally tied up with the health of the environment in which they live and work. And this, of course, includes the effects of ocean acidification, as well as a long list of other stresses. The structure of the program is described by a double-hulled voyaging waka, which was used extensively by Pacific people as they moved about the vast Pacific Ocean. One hull represents well-being and the other hull represents the marine environment. These are interconnected by a series of themes and projects. The waka is driven by two sails, innovation and voyaging. And there are two tumu, or mooring posts, training and monitoring. And this includes ocean acidification parameters. Governance and management oversight is described by the star cluster here called Matariki in New Zealand, but known by other names around the world. You might know it as Pleiades or Seven Sisters. As part of the monitoring tumu, we offer a core suite of measurements to the community. Temperature, salinity, pH, light. In fact, these are the GOA-ON Goal 1 Level 1 parameters. After consultation with the community, we add additional parameters that are important and relevant to them. This may be related to a local species, for example, paua, a type of abalone that's important in New Zealand, or it may be to do with their local environment, such as the health of the kelp bed. When working with local communities in a holistic way, the management of data becomes really important and can go beyond the FAIR principles that we generally apply and think about in the biogeochemical community. Taking care of the data also needs to be considered. Having respect for the data, using it responsibly and ethically for the collective benefit. I'm also interested in the ways that we can use different types of data, particularly historical data and information from stories and place names. This potentially allows us to extend our time series information back in time as well as going forward. I'd like to thank the many people in New Zealand who are contributing to the New Zealand Ocean Acidification Observing Network and therefore to GOA-ON Goal 1, improving our understanding of global ocean acidification conditions. I'd particularly like to thank Judith Murdoch, who manages the New Zealand Ocean Acidification Observing Network. And finally, I'll finish with a whakatoki, a Māori proverb from the Ngāti Wai people in the north of New Zealand. E tangi ana ngā reanga o utu, e mahara ana ngā reanga a tai mai ta aha rā e whakamahana taku ora kia tina. When the land, river and sea creatures are in distress, then I have nothing to be proud of.